Hi guys, in this tutorial I would like to show you how to use the SD card. Now before we start we need to make some preparations. The SD card is usually handled by software from the Zynq, but we still need a design. So I'll use my design of the DMA that I showed you in DMA part 1, and I'll go to my DMA repository, copy the link. I'll go to the demo directory I prepared, and I'm using SVN software to check it out. SVN has two folders as default: branches and trunk. My design is in trunk, so I'll check out it, and I'll check it out to my demo directory. And we have our project. This project was done with the Vivado 2021.2. So I'll open Vivado 2021.2. I'll cd to my demo directory, work, and source the script. Now in this project I didn't use all the big method of saving everything external to the project, because it's a very simple project. It's just a block design with a wrapper. I generated the tickle script using the recreate block design using tickle. So I have here the whole project in just one tickle script. I'll generate the bitstream, and we'll move on to the next step in the preparations. Now to use an SD card we of course need an SD card. So I have one here connected to my computer. Here. Now it's very important to make sure that the file system the SD card is using is correct. So I'll format it to FAT32 as default. Quick format will do. And the SD card is ready. Now in the DMA tutorial we use the example from the Vivado. In the example we generated the data before we transfer it to the DMA to be transferred to the DDR and back. In this tutorial I will use the same software, but after generating the data I will read from the SD card a bin file which I prepared. This is the bin file I prepared with 30 hexa bytes from 1 to 48. 30 hexa is 48 in decimal. So I'll have this file. The file name is idma.bin, and I will use it. I will copy it to my SD card, and now my SD card is ready, so I can eject it and I will put it in my board. Now The bitstream is not ready yet, so I'll stop here the video and I'll come back when it's done. Now that my bitstream is done and I have no timing issues, we can start on the software. We'll export the hardware with the bitstream into my software directory. And we launch the VTs. We'll direct it to our software directory. And we'll create a project. We'll use the XSA we generated in our software directory. And we'll call it DMA with SD with ARM0, and we use an apply application. Now we'll import the software that we did in the demo, in the DMA tutorial, and we can start working on the software. If you remember, we changed the check data to check the data according to not generate it again, according to RX compared to the TX. Now the first thing we need to do, the default for the VTs in the FSBL, we have a software package for the SD card. In the FSBL it's included automatically because the FSBL must approach the SD card to load the software. But in regular software it does not, so we have to include it manually. And we have to include it in our file. This package has all the structs needed for the file system of the SD card, all the functions to work the SD card, and some parameters to use with it. So here we have it. Now, before we can use an SD card, we need to mount it. It's just another drive, so we need to mount it for the Zynq. Now, the software is built with main, which calls the simple polling example, which is the main part of the software, and which this calls the check data. So we'll mount the SD card in the main, and we unmount it when we finish also in the main. The mount function is here. We'll copy it. We'll put it before we go to the main part of the project. And let's see what we need here. First we need an fResult variable. We'll call it RC. And we'll have it. The RC, the fResult, give you indication of did the function succeed or not. FROK means the function succeeded. If it didn't, we have some kind of errors here. We need a variable for the file system, and we put it globally because this is needed all over the software. And we'll address it with a pointer. Now we need the path to the SD card. The path for the SD card will be 0, and we leave here only the path. And we need one to mount the SD card. Now I'll add an error message that if this didn't succeed, we'll know about it. So if RC is not FROK, we'll give a message and what the message is. Now after we mount it, we need to unmount it. We'll do this at the end of the main, and instead of 1 we'll use 0, and we unmount the SD card. Now here all the start is the DMA configuration. We went over this in my DMA tutorial. I'll skip right to here, which is the generation of the data. We generated the data as a simple counter, and this is the data we used in the DMA tutorial. Now after this, I want here to read from my SD card and overwrite the data generated by this software. So to start a file, first we need to open a file. This is the function fopen to open a file. Again, we need a result, an F result. We'll add it here. And again, RC. And we'll add here RC equals. Now we need a fill variable. Now we want to read and we want to write, so I distinguish this with an R. So it's for read. Next we will do the write. I'll have a W. And we'll address it with using a pointer. Now we need a name. Now we can use just a string. So we'll use just a string. We'll use the path for the SD card, which is this. And if you remember, my file name was idma.bin. Now, in which mode we want to open this file? We want to read, so we'll use the FA read. And of course, we'll have the error message. Just not fmount, fopen. Now the next thing we need is to know how many bytes we have in this file. So for that, I will make an init variable which I'll call read size, and in the RFP, now the fill variable has many objects about the file, a lot of information about the file, the fill. So I'll take the RFP. In it I have an object field, and in it I have an object size. This is the size of the file in bytes. So this is actually how many bytes will I read from the file, and I can use in my software. I'll also use a data size variable, which will be equal to the read size, because all over the program I'm using how much data I have, and in the old software we use it as max packet length, which is 20, and we have 30 bytes. So all the packet length I will change to data size, most of it, because the generation is still going to be 20 bytes, but the buffer for the will be data size, the DMA will be configured to data size, and the checker will be configured to data size. Of course, we need to add this variable as a global variable. Now I'm using two variables for the data size because this is a local one and can be seen during debug, and this is needed for the rest of the software. We need to point to the beginning of the file and start reading from the beginning of the file. This is a function FISEEK. This one, we'll add it here. Again, the RC and the error message. And the RFP, again as a pointer. And the size, we're starting at 0. Later on I'll show you if I don't want to start at 0, but for now we're starting at 0 because we want to read the whole file. Next, everything is ready, we can read the file. So we have a function of reading the file. We'll add it. Again, the RC. Again, the error message. And again, pointer to the fill location. For the buffer, we want to read it to the TX buffer. So we'll put here the TX buffer. We need to put how many bytes we want to read. This is the R size bytes. So we have it here. And we need the BR variable. We'll add it here. And we'll address it as a pointer here. And actually that's it. We finished reading the file. The last thing we need is to close it. So we'll take the fclose function, add it here with its RC, with its error message, and with the pointer for our file. So actually that's it. We have in the TX buffer, we have the data from the file, and we can launch the DMA. After we finish the DMA, here if you remember, the Zynq is actually using a cache. So actually when we wrote the data, we actually wrote it to the cache. We need to transfer it to the DDR here. And if we want to read back, we need to read back the data from the RX DDR buffer into the cache, so we will have the data ready for the Zynq to write. The next thing I want to do is to write it back to a new file and to show you how to write. So actually writing is very similar to reading. So I'll take the whole part of the software here, and we'll do some changes. First of all, like I said before, it's better to use a specific variable for each file. So I'll add here a write FP. Now I'll go here, and all the read FP from the write, this is the read and this is the write. So we'll change the read FP from the write to the read, from the read to the write. Okay, we don't need IDMA because we don't want to write on the same file, so we use outDMA. And we're not reading it anymore. Now we need to create it or to open it. We have create new, create always, and open always. Open will do. So we're actually opening the file if it exists, or if it doesn't exist, it will create it. And we have an FA write because we want to write. So this is the file open. We don't need the pointer here because it's a brand new file and it's had nothing in it, so it's already in 0. And instead of read, we need to write. So we'll take the write function. This is it. We'll change first the RC, fwrite to fwrite, pointer to a write file. The buffer we want to write is the RX, so we're writing the RX. How many bytes? Again, data size, the same bytes. And init BW now. As a pointer. And that's it, and we close the file. So actually we read the data from, this is how you read binary data from a file. You open it, you set the pointer, you read and you close, and here you write for the file. You open it, create it or write it and close it. So actually this is the software for read and write from an SD card. We can save this. And we can compile it. And I'll put my SD card in my board and connect it to my computer. And the compilation was done, so we can run it. I'll use debug so it will be easier to follow. Debug configuration. Everything is ready. We program the device and we can start debugging. Now I'll prepare my char term. And we can see the messages from my software. First we have the first message. And now we can mount the SD card. And the SD card was okay. So it was mounted. And now we're going into the simple polling example. Okay, now the first thing we need to generate the TX buffer and the RX buffer. We'll configure this and we'll look at it. And here my TX buffer is ready. And my RX buffer is ready. Now the DMA configuration I showed you in my DMA tutorial, so I'll just skip over that. And we're here for the data generation. And we generate the data until we read from the file. And here we have the original data from C, D, E, and so on until to B, 20 bytes. Now let's look at the read function, how we are reading from the SD card. First we open the IDMA file and we're okay. Next we read the data size and we have 48. Like I said, we have 48. Now here is my data size. Now here I can show you why I put it. I see it here. So to go back and forth from here to here, I used another variable here for read size. Now we address the pointer. We're okay. And now we will read. Here is my data and read okay. And here are my numbers 1, 2, 3, 4, blah 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 until 48. So we read the file. The message was okay. Now we can close the file. We'll flash the cache, so we transfer actually from the cache to the DDR, so the DMA can work on it. We fetch the RX as well, but there's nothing there. And now we can work the DDR. Now if you remember, the DDR have the weight here, the configuration and so on, so we just skip to that until we have the DMA finish writing. And nothing happened. Actually, the DMA worked and the DDR have a new data, but the software doesn't know about that. So for this we need to flash the cache again. Here we flash the TX, nothing happened. And here we have flashed the RX. And here are the data from the DMA 123 till 48. Everything worked well. So now we want to write this to the SD card, to the out.dma bin. So we'll open the out.dma bin. Everything is fine. We'll write the data and we close the file. So now we have a new file in the SD card. We can't see it right now because the SD card is in my board, and we just let the software finish. Here, this is how the software finished in my tutorial. So we can check out the SD card. I'll eject the SD card from my board and I'll put it in my computer. And here I see two files. Here is the DMA that I prepared in advance, and here the odma.bin. The Zynq write in capital letters. And we can check this out. This is the IDMA, input DMA, which we prepare in advance, 123 until 48, 30 byte. And here is the output. Exactly the same file. So we read from the file, we run it through the DMA, and we write it back to a new file. Now, this is how you read and write from an SD card. And this is for binary file. I want to show you also how to use text file. Actually, the read and write from the SD card will still be binary, but we need to address the text to be written as binary. And this video turned up to be very long, so this I will do in another video. Thank you very much.